Hi. So section 5.5, I talked about it a little bit. So remember we introduced inverse functions, inverse trig functions, and in order to define an inverse function of a given function, one condition must be met by the function whose inverse we are taking, that it must be one-to-one function. What does it mean by one-to-one function? Well, it means for every y in the set in the range, it must be mapped by only one x from the domain. So here is an example of one-to-one and not one-to-one. So if you note here, in this case, the y, there are three y's, and 16 and 4 are being met by -4 and 4. Or in other words, there are two domain values that are going to the same y value. So this should not happen. Each domain value must go to a different or a unique y value. So then it is a one-to-one function. So for example, this function shown in green, this is a one-to-one function. How can we quickly check whether a function is one-to-one or not? If we have a graph of the function and we draw a horizontal line and it passes through more than one point of the graph, then we say the function is not one-to-one, and that is called the horizontal line test, which is stated here, and these are the two examples shown. This is not one-to-one, and this one is one-to-one. Why? Because you can see, you pass any horizontal line at any place, it will only cross the function in one point. So now when we talk about the inverse trig function, so we start with the sine y is equal to sine x. Now when we look at y is equal to sine x, if I draw a horizontal line anywhere, it will pass through the function anywhere between -1 and 1. It will pass through the function infinitely many times. So it is not a one-to-one function. So what we do in this case, we try to restrict the domain. How do we restrict the domain? Well, we want to cut off a chunk or a piece of the sine function and check whether it is one-to-one, and maybe it satisfies some conditions. So if we take this function as from between 0 and pi as our piece, then you can see it is not one-to-one. So this is not a good piece. And if you take from here, that is also not one-to-one. So but we notice that the function over here, the one shown in red here, this one is a one-to-one function because there is no horizontal line will cross it more than once, and the domain is -pi/2. So this value is -pi/2, and this is pi/2. So the domain is -pi/2 to pi/2, and the range is -1 to 1. So this is also what we wanted the range to be, taking on all the full values of the sine range. So remember, the range of sine function is the -1 to 1. So here is our restricted domain. This is the restricted domain sine function, or sine y is equal to sine of x with restricted domain. Okay. Restricted domain. So domain is -pi/2 to pi/2, and the range is -1 to 1. So what we do now, we say, okay, now we have restricted domain, so we can take that as our sine function and define the inverse sine function. So we say that y is equal to sine inverse x. So we write it like this and we read it as sine inverse. We do not say sine raised to the power of -1. So you have to remember that sine inverse x is not 1 over sine x. Okay, so remember, if I have x to the -1, I can say 1 over x. If I have 3 to the -1, I can say 1 over 3, and so on. So why can I do it here? Well, these are numbers. This is not a number, this is a function. So these are numbers. So in numbers we can do that, but not with functions. But why do we use this sign or this -1? Well, this is kind of a notation that is used in upper level math or mathematics, so it's just like that. But later on, scientists were able to come up with another way of writing it, and that is the arc sine x. So arc sine x is the same thing as sine inverse x. Anyhow, so when we define the inverse function, well, the graph of the inverse function will look like this, but you are not responsible for knowing the graph. What you should know is what is the domain and what is the range of the inverse function. So the inverse sine function y is equal to sine inverse x. One thing you must know, that if and only if sine of y is equal to x. So note here, this sine kind of moved over there and the inverse went away. Okay, so when we move the sine function, or when you apply the sine function of this equation, so you can look at it like this. We apply sine here and we apply sine on this one. So the inverse and the sine and sine inverse, they cancel each other and we get x. Now this is something you will see later. This can be only done if x is in the domain of the sine inverse. So if x is in -1 to 1, okay, because remember the domain of the sine will be inverse will be, so domain of sine inverse x is -1 to 1, and range of sine inverse x will be -π/2 to π/2. So as I mentioned earlier, the inverse sine function is also called arc sine and is denoted by arc sin. So this is the same thing as I mentioned up there. Arc sine x is the same thing as sine inverse x. Okay, so we can define the cosine inverse as well, but let's first look at these examples. It says find the exact value of each expression. So sine inverse of 1/2. Now in order to do that, find these values, let's look at something else first. Now you saw this the sine function which we are given. So if you note here the value that the sine function takes, the range values lie between -1 and 1. So if I want to find an angle, a t value, sine of t is equal to 1/2. Okay, sine of t is equal to 1/2. So now I want to know sine inverse of 1/2 is equal to what? And so we know this thing, that if sine of t is equal to 1/2, we know that t will be equal to π/6, but also it will be 5π/6, but also it will be 13π/6. and so on. There will be infinitely many values actually. But even with these two values, you will notice that when we are asked about sine inverse 1/2, we cannot say that this is equal to these two values. Okay, so the reason is because now we are working in restricted domain. So sine inverse x, the values of sine inverse x will lie in the interval negative pi over 2 to pi over 2, which means here, so on number line it makes more sense. So here is 0, here is negative pi over 2, and here is pi over 2. So any value of sine inverse x will lie in the x or will lie in this interval negative pi over 2 to pi over 2. If you write a number which is outside this interval, it's wrong. So for example, now sine inverse 1/2 we know is true when or that it is the same as finding the t value when sine of t is equal to 1/2. So this is going to happen in many places, but right now, because we have to only take the number or the value that lives in our interval negative pi over 2 to pi over 2, which is pi over 6. So the answer to your first part here will be pi over 6. Now what about arc sine or sine inverse of square root 2 over 2? So you have to look at, basically if we don't know this value, you can say is equal to x, and now according to the definition I can say square root 2 over 2 is equal to sine of x. So now we are looking for an angle which or a number x for which the sine of x is square root 2 over 2. So that's why I have mentioned that please memorize that table, because if you know that the sine of pi over 4 is square root of 2 over 2, so as soon as you see this equation, you know that one value of x is pi over 4. Then also sine of 3 pi over 4 will be square root of 2 over 2. So another value for x is 3 pi over 4. Actually with these two values as well. So when we come here, we are not going to say there are these two values. Why? Because 3 pi over 4 does not lie in our interval negative pi over 2 to pi over 2. So this is the answer to part 2 is that x is equal to pi over 4. Okay, now coming to the third piece, sine inverse of 0. Sine, so again we say let this be x, then it means we are looking for 0 is equal to sine x or sine x is equal to 0. So where is the sine of x 0? Well, it is 0 at, if you recall, so sine of x is equal to 0 means x is 0, it will be 0 over here and it will be 0 over here, because this is 1 0 and negative 1 0. So this is happening at x is equal to 0 and at x is equal to pi, but pi doesn't lie in our interval, so answer will be that x is equal to 0, or in other words, or sine inverse of 0 is 0. So here I can say sine inverse of square root 2 over 2 is pi over 4, and here in the first one sine inverse of 1/2 is pi over 6. Okay, the same way we can define the cosine inverse function, but for the cosine, to restrict the domain, we cannot do the same interval, because this is negative pi over 2 and this is pi over 2. So you can see in this interval the cosine is not 1 to 1. So it is 1 to 1 between 0 and pi, so that is will be our interval. And the same way we will define that y is equal to cosine inverse x if and only if cosine of y is equal to x, and the domain was restricted. So this function here, y is equal to cosine x, that had the domain 0 to pi and had the range -1 to 1. Now inverse function will have the domain as -1 to 1 and the range will be 0 to pi. So now when we are looking for the inverse cosine values, we will be looking in the interval 0 to pi, not the -pi/2 to pi/2. And again, warning that cosine inverse x is not equal to 1 over cosine x. Okay, so looking at some examples here. So what is cosine inverse 1/2? So how will you find it? Well, again, if you don't quickly remember, you can always say this is equal to x, so that by definition I get 1/2 is equal to cosine x. Okay, now I am writing it like this so that you can understand that basically what is happening, this cosine is going on the other side and the inverse disappears. But you are not supposed to do like this. You are not supposed to cross it and put the cosine after the x. That doesn't make sense. That is like saying what is the value of this, which doesn't make sense. Okay, so if you want the square root of 25, you put the square root first and then 25, not like that. In the same way here, when you are you are finding cosine of x, if someone asks you what is the value of cosine, well, you cannot tell, because cosine is a function which has to have some argument in it, something to act upon. So make sure that you write it correctly. So now when I look at this equation, so it means we are looking for an x value of x such that when we take the cosine, we get 1/2. So again, if you recall the table values, the cosine of pi over 3 is 1/2, and also cosine of 5 pi over 3 is 1/2. Okay, again, how? Well, so cosine is cosine is positive in the first quadrant and in the fourth quadrant. So when this is pi over 3 or this is the reflection of this point over here, so the terminal point here was square root of 1/2 comma square root of 3 over 2. So the reflection will be 1/2 negative square root of 3 over 2. So the cosine is the x coordinate. So cosine of this value, which is pi over 3, so cosine of pi over 3 is 1/2, and then same thing, cosine of 5 pi over 3 is 1/2. If you look at cosine of 2 pi over 3, that will be negative 1/2, and if you look at cosine 4 pi over 3, which is in third quadrant, you will get negative 1/2. So we are not looking at the negative value, we are looking at the positive one. So it has to be in first quadrant or in the fourth quadrant. So we might say both, but remember we are looking at inverse function, the value for the inverse sine, cosine. So it will be only one value. So inverse functions have only one value. So you will get, because we are now looking for values in 0 to pi, so that cosine inverse of 1/2 will give you that x is equal to pi over 3. So what is arc cosine of square root of 2 over 2? Again, you can say is that this equal to x, and so we get square root of 2 over 2 equal to cosine x. Again, going back to our little table or unit circle, whatever you prefer, you can see which value or cosine of what value or what t value is equal to 1/2. So is equal to square root 2 over 2. So you notice that cosine of pi over 4 is square root of 2 over 2. And in the same way, cosine of 5 pi over 4 is also actually 7 pi over 4. So in the fourth quadrant, it will be 7 pi over 4 is also square root of 2 over 2. But we are looking in the interval 0 to pi, so the value of x here will be pi over 4. Then cosine of 0, the cosine inverse of 0 means we are looking for an x such that cosine of x is 0. And this can happen when x is pi over 2 here or 3 pi over 2. Okay? Now, we are looking between the interval 0 to pi, so x will be equal to pi over 2. Now the tan inverse function, so we have the similar situation. We have to restrict the domain. So where should we restrict the domain? So common sense kind of tell us that we should restrict the domain between negative pi over 2 to pi over 2. Okay? Now if someone asks why can't we do from pi over 2 to 3 pi over 2, well, we can, or we can even define it from negative 3 pi over 2 to pi and negative pi over 2, or to the next piece, whatever that is. But the thing is, then there are so many of these, infinitely many pieces, so every person can have their own definition of the inverse tan function, for example, and then it is, what is your answer? Where are you looking at? So in order to avoid this and universally come to a one suggestion or one conclusion, it's more common sense to take the interval negative pi over 2 to pi over 2. So we remove these two. So here we are looking at the one piece from negative pi over 2 to pi over 2, but in this case the negative pi over 2 and pi over 2 are not included in the interval, because you can see that it is approaching negative infinity here, and that's this one up here is approaching positive infinity. So same way, because it is not one-to-one function, so we have restricted the domain. So the domain here is negative pi over 2 to pi over 2. So now I'm not using the bracket but parentheses, and the range is going to be, in this case, negative infinity to infinity. So for the inverse tangent function, the domain will be negative pi over 2, negative pi to pi, and the range is negative pi over 2 to pi over 2, with the pi over 2 and negative pi over 2 not included. Okay, the writing, it is also shown by tangent inverse of x or tangent inverse of t and arctangent of t or arctangent of x, but we abbreviate it like this, arctan. This is what the graph of arctan, and this is very important that you remember this one, this graph. This is going to be present in Calc 1 a lot. So if you note here, the asymptotes, this is pi over 2, right? Y is equal to pi over 2, and this bottom one is y is equal to negative pi over 2. So these two were vertical asymptotes in the tangent x, but now they have become horizontal asymptotes. And then now we look at this example. So what is tangent inverse of 0? So again, you are looking for some x value such that tangent of x is equal to 0. So again, if you remember your table, or if the table is in front of you and you look at it, so you want to find out what t value or what x value is the tangent is equal to 0. So you will notice that it is equal to 0 at 0 and at pi in 1 unit circle. So then which value we take? So remember, we are looking at the value. So it's easier for me to do this, that I am looking for values between negative pi over 2 to pi over 2, and I think it will make more sense if you take it horizontally between negative pi over 2 and pi over 2. Somewhere here you have 0. So we are looking in this interval. So which means our x will be equal to 0. So in other words, tangent inverse of 0 equals 0. Similarly, we look at this one, saying let's say this is equal to t or x or any variable. You can take y equal to z equal to theta equal to alpha, any value. So which means tangent of t is equal to square root of 3 over 3. Again, now you have to go back to your table and see what t value has its tangent equal to square root of 3 over 3. So you will notice that this is when t is equal to pi over 3. So arc tangent of square root of 3 over 3 is equal to pi over 3. Okay, next is tangent inverse of x, or tangent inverse of 1. So which means again t. Okay, this time I am going to take it to equal to theta, just for a change. Okay, so let's say this is equal to theta. Then we can say tangent of theta equals 1. So what is theta? So which angle has its tangent equal to 1? If you go back to your values, table of values, or the unit circle, this will happen. This can happen actually in the first quadrant or the third quadrant, because these are the two quadrants where tangent is positive. So the value could be, so theta could be pi over 4, or theta is equal to 5 pi over 4. But 5 pi over 4 is not in our interval from negative pi over 2 to pi over 2. So this is the only value that satisfies our given result. Okay. So I will stop here and do next video, which is just now we will be solving finding bunch of values of inverse functions.